Hello grade 8s, this is Mr. Miller and welcome to lesson 3.2 on exploring the Pythagorean relationship. So first of all, a right triangle is a triangle that has a right angle, which is a 90-degree angle, in it. In a right triangle, the longest side is opposite to the right angle and is called the hypotenuse. The other sides are called legs. So let's highlight some of these things. When we're talking about the right angle of 90 degrees, we're talking about this angle right here is 90 degrees, and that little box in the corner is the way to indicate it. Now, as for the longest side, which is opposite to the right angle, the longest side is what we call the hypotenuse. So in this case, it is this side length right here, and its length is C. So the other two sides, the other sides are called the legs of the triangles, and so we're talking about A is one of the legs, that's the length of that side, and this is the other side length as well, which is referred to as a leg, that's B. The Pythagorean theorem tells us the relationship between the lengths of the sides in a right triangle, and that is that a squared plus b squared is equal to c squared, where a and b are the side lengths for the legs and c is the side length for the hypotenuse. Okay, so let's write that down in words. It'll help solidify this idea. So what we say is that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Okay? You should write that down. Let me just do a little bit more highlighting here to really explain this. When we're talking about the square of the hypotenuse, again, the hypotenuse is what we've labeled as C. The square of the hypotenuse in the Pythagorean relationship, that's C squared. And it is equal to, so when we're saying is equal to, there's your equal to signs. The sum of the squares of the other two sides, that is your a squared plus b squared. Okay? So it's the sum of the squares of the legs of the triangle. Now you might look at this and not be entirely sure what it means. It might help a lot more if you see some specific numbers. And so let's take a look at the first example, and it'll help to solidify this idea. Example 1 is asking which of the following triangles is a right triangle. So let's do our labeling as we did in that diagram at the top. We're going to call the longest side C, and we're going to call the other sides A and B. Now it doesn't matter which one you call which, but it does matter that you identify the longest side, and that's the one that's going to be opposite the 90-degree angle, and we're going to use C. And what we're going to do here is we're going to take a look at the value of a squared plus b squared. Now a squared plus b squared in this case is equal to 4 squared plus 3 squared. Now we've just studied about squares. When we do 4 squared, it means 4 times 4, that's 16. 3 squared is 3 times 3, that's 9. And when you add these two together, that gives you 25. And notice that when you do c squared, this is equal to 5 squared, which is also 25. So in this triangle, since a squared plus b squared is equal to c squared, where c is the hypotenuse, this is a right triangle. That's the conclusion that we can draw. So let's see if that is true in the case of the next triangle for part B. First of all, let's identify the longest side, and we'll call it C. And again, it is opposite to the right angle. Let's call these two sides A and B, and let's check out the value of a squared plus b squared and compare that with c squared. So we've got a squared plus b squared, which is going to be equal to, in this case, 5 squared plus 11 squared. So that's 25 plus 121, which gives you 146. Let's see how that compares with c squared. Now, c squared is 13 squared. 13 squared is 169. Different results. Here, since a squared plus b squared is not equal to c squared, that means that this is not a right triangle. Okay, and so what I'm going to do here is I'm actually going to erase this right angle here. This angle is actually not a right angle. It is either more or less than 90 degrees. And if you're pretty bright, you could probably figure out which of the two cases that is. Alright, so let's go on to some more examples. In example 2, it says, given the areas of the squares of two sides of the sides of each right triangle, find the area of the square on the third side. So here we have an area of 49 square centimeters, and I'm going to call this a squared. And this area, 576 centimeters squared, I'm going to call that b squared, because they are the squares that are on the two legs of the right triangle. Here, this is going to be the square that is on the hypotenuse. So this is C, okay? And it will have an area of c squared. Of course, we know that c squared is equal to a squared plus b squared. So all I have to do to find this area is add 576 with 49. And that gives me 625 square centimeters. Okay? Let me just double check that with my calculator, make sure that I haven't made a mistake there. 576 plus 49 is equal to 625. Okay, in part B, this is c squared. It's the square on the hypotenuse. This, it doesn't really matter whether you call it a squared or b squared, but let's call it b squared. And so I need to figure out, I know that this is going to be A, and this area is going to be equal to, well, it's the area that when I take this area and I add it with 225, I should get 289, so I should be able to subtract to find that area. So 289 minus 225, and this gives me 64 meters squared. Okay, and again, this is just another use of the Pythagorean theorem. Now, in example 3 here, we want to take a look at what is a Pythagorean triple. Okay, so a Pythagorean triple is 3 natural numbers that satisfy the Pythagorean relation, which is to say that we've got three numbers a, b, and c, then a squared plus b squared has to be equal to c squared. Okay? So, in other words, we're talking about a Pythagorean triple, so it's three numbers a, b, and c, such that each of a, b, and c are in this set of numbers. Okay, the natural numbers go like this: 1, 2, 3, 4, 5, and so on. Okay? In other words, no decimals allowed, no negatives allowed, not even zero allowed. Okay? And we also must know that a squared plus b squared is equal to c squared. So, 3, 4, 5 is a Pythagorean triple because 3 squared is 9, 4 squared is 16, 5 squared is 25, which is equal to 9 plus 16. Here are some others. If you take 3, 4, 5 and you double it, you get 6, 8, 10, and that's another Pythagorean triple. And you can verify that with your calculator very quickly. Right? 6 squared plus 8 squared is equal to 100, which is 10 squared. Let's double check that first one. 3 squared plus 4 squared, make sure I didn't make a mistake. Yep, that's 25, which is 5 squared. Here's some other ones that are useful to know. 9, 12, 15. Okay, 9 squared plus 12 squared is equal to 225, which is 15 squared. All kinds of other ones. Anytime you take 3, 4, 5 and you multiply it by something, like let's say multiply it by 4, 12, 16, 20, 12 squared plus 16 squared is equal to 400, and that is 20 squared. A few more. 5, 12, 13. You can verify that with your calculator. 5 squared plus 12 squared is equal to 169. That's 13 squared. How about 8, 15, and 17? And let's do a little bit different order this time. Let's say that I have 17 squared. That should be equal to 8 squared plus 15 squared. So if I subtract away the 8 squared, it should give me 225, and that is equal to 15 squared. I'm changing up the order a little bit on purpose because it will help us to be able to solve some of these problems later on with right triangles if we're able to do this in a different order. So again, 7, 24, 25, this is another Pythagorean triple because 7 squared plus 24 squared is equal to 25 squared, or you could do 25 squared minus 7 squared, and that should give me 24 squared. 576, let's see, the square root of 576 is equal to 24. So yep, that is also a Pythagorean triple. And there are infinitely many of these, but these are just some. Okay, so there you go. There is the regular assignment and the honors assignment for this section. And let's see how we're doing on time. We're going to stop it there. And if you're interested in the proof on the Pythagorean theorem, check out my Google Calendar. There's a link there to a website that's got a really cool interactive display that proves the Pythagorean theorem. Thanks for watching, and bye-bye.